Hi, my name's Amy Kinsel. I'm Dean of Social Sciences. It's my pleasure to introduce everybody here and welcome you to this afternoon's talk. Farming of the Future, Feeding Everyone in the 21st Century with Nick Begley, who's a graduate student at the University of Washington, Bothell. So the subject of this talk concerns agricultural production and sustainability. So everyday images you see, regular farms, barns, silos, horses, pigs, cattle. Is this sustainable in an era of population increase, of climate change? Nick's been looking at indoor farming as a sustainable alternative to traditional farming, and he's also looking at social and ethical issues of equal access to food. So he's going to be addressing some of those topics in his talk today. Nick is a 2014 graduate of Shoreline Community College. He's currently a graduate student at the University of Washington, Bothell, working on a master's degree in policy studies with an emphasis on sustainable agriculture and public health. He's looking at how to support underserved communities in his policy and research efforts. He was awarded the University of Washington Bothell Founders Fellowship last year, and he's done quite a bit of research on agricultural crops and using different hydroponic methods to do agriculture. So he hopes eventually to play a role in shaping policy on agricultural production that's more sustainable and equitable for the future. So please join me in welcoming Nick Begley. It's very good to see him back here at Shoreline. Thank you very much.
Okay, thank you very much. It's a really exciting opportunity to be able to come back to, as what we just heard a few years ago when I graduated from Shoreline before I went off to UW Bothell. I got interested in sustainable agriculture and public health because I felt there was a really strong intersection between the food that we eat, how we process that food, and not just the effect on our overall human health, but as well as the environment. And I found that there to be a lot of different connections. So we're going to dive into a lot of concepts today. So any clarification needed on something, I'll be more than happy. We have kind of a small group, so that'll actually make it a lot easier for this to flow. So again, yes, the title is Farming of the Future, Feeding the World in the 21st Century, and let's look at how we might be able to do that. I think it's important with any lecture for any future academics or students that we establish learning outcomes or learning objectives for the crowd that we're reaching out to. So I'm going to breeze through this real quick and kind of give you an overview of what this presentation is going to look like over the next 35 minutes or so. We're going to look at the historical processes of agriculture, starting with early innovations, moving into the Industrial Revolution, as well as what a future agriculture systems may look like. We're going to talk about threats to the current conventional model, in particularly climate change, population growth. We'll also be looking at, like I said, the connection between that human and environmental health with the way that we produce and consume our food. We'll also be looking at a definition, working definition for everybody of what hydroponics, aquaponics, and aeroponics really means. I mean, you may have heard these terms before. We'll kind of give a little bit of a clarification about that. As far as research opportunities, really we'll talk about my research and some of the stuff that I get a chance to work on. Being a student at UW Bothell, a very interdisciplinary type campus that allows me to focus on public health issues and then also have the opportunity to work on directly bench-related science and things like that. So, and we'll talk about some of the potential benefits of new technology, what this looks like, and but also just as important to talk about the benefits, I think it's just as equally important to talk about the limitations. The limitations or some of the obstacles and hurdles that we face when we talk about the social and cultural implications of really moving away from our traditional models and going into something that may seem a little bit more high tech. So, and then for students in the room, hopefully we'll be able to draw some connections to our career and future career and academic opportunities. So let's begin. So around the year 10,000 BC marks a period of human evolution that takes us from the nomadic hunters and gatherers into what's called the Neolithic period, or otherwise known as the New Stone Age. One of the main characteristics of this time is when human beings had first started to really establish themselves in colonies or communities, started engaging in subsistence farming. And this allowed for people to grow and innovate and change the way we did things, come up with new technologies that made it sustainable, or at least from a calorie standpoint, sustainable to live in a certain area and then grow those communities outwards. We brought in the domestication of plants and animals, and then as you see evolution over this time period, where bringing in animals to move tractors or move plows or hoes. So this is a really huge step in our evolutionary period, because it really marks a time where we really started to make those advancements. Flash forward about 10,000 years or so, and then we've now entered into the Industrial Revolution. Why does the Industrial Revolution make sense for an agriculture conversation? Is because this is a time where we really ushered in brand new inventions like the steam engine that allowed us to take trade across the globe, and now we're reaching into far stretches. And we moved from that subsistence model into a model that was more based on trade and production and large-scale inventions that were needed to make that possible. Upper right-hand corner, you see the onset of the seed drill by Jethro Tull, which made planting more efficiently, going from a scattering method to a more efficient method, and then down into the lower pictures, more like the earliest 20th century. Period of the 1960s marks what a lot of people call the Green Revolution. What this signifies is when now global production is global agricultural production is a major part of our global economy, and the efficiency models are really ramped up from this point in time. This is when we start bringing in what we think of today: the pesticides, herbicides, fertilizers, highly efficient tractors, highly mechanized systems. And if you see, there's certain characteristics between these three sets of slides. In the first two slides, you still see a lot of human beings engaged in our agricultural process. And then as we moved into the Green Revolution, you start seeing less and less people who are actually engaged in that. Why that may or may not matter, we'll try to draw those connections later. So the talk today: are we poised, or are we moving towards a new Green Revolution? Are we needing to look at new models of how our food is produced? What kind of facilities are able to produce those? Are we able to retrofit buildings into full-scale farms? Are we able to utilize vertical growing space, vertical technology to maximize our yields? And what does that look like? And are we moving towards a model that brings people back to the agricultural center and everybody's engaged in that process? Or more people can be re-engaged in that process again, because, like I said, back in the 1960s, or really up until the 1960s, still small-scale sustainable farming on an individual level was very much a part of our culture. Even up until World War II, there was huge efforts for people, victory gardens and self-sustainability and things like that. So it was really a huge shift in thought until where we are today. So why this talk, why this lecture, why this topic, why would we do this? Food seems readily available, maybe not as accessible to everyone as we'd like to, but from a visually standpoint, it seems that food, everywhere we look, food is available, so why would we even need to really change the model? For the first time in human history, we have higher rates of obesity than we do with famine. So it seems that, as of on face value, that maybe these things are working out just fine. So we're going to look at three things that I've identified as sort of what we talk about as why we might need to move away from that model. And one is impacts of climate change, population growth, and then back to that human and environmental health component of how we produce and consume the food. So if we look at climate change, I think we come and we think about what climate change on a direct level, and we think of rising air temperatures, rising CO2 concentrations. These are things like, not just that, but also changing climates in certain regions that may or may not. So rainy places that are now dry places that are now rainy, hot places that are cold, and so on and so forth. So it's not just these direct exposures, but a lot of these are what I think a lot of us identify as the main components of climate change. So depletion of usable water, obviously this, maybe not obviously, but this relates to just our ability to be able to process these water, have usable water, clean water that's not contaminated or depleted from overuse. Indirect effects, things that we don't necessarily think of right off the bat, leads to the rise of pests and other invasive species due to some of the processes that we're engaged in now. Increase in weeds, simply weeds growing in agriculture, especially in our outdoor soils, and due to over pesticides and fertilizer use have lead to disabling factors that are decreasing our overall agricultural production, and the increase of pathogens, and a lot of this has to do with lack of biological diversity within our soil, our fungi, our nematodes, and all the other microbes that are in the soil that are interacting, and that moves a little bit into our research later. And then there's the aggregate effects. These are effects of all these other processes that are happening, rise in all these warming temperatures. We see now, and we know now that there's a huge soil degradation and erosion issue that's happening all over the globe. Soil is becoming less and less biodiverse. We're able to do less and less with the soil, and we're getting less and less of the yields in response to the work that we're putting into it. Which overall leads to the decrease in agricultural production and irrigation system failures. Things like the snow and winter processes, ice caps, things, ancient irrigation systems are drying up. I mean, we don't have to look as far as California, but examples around the world like India and other places that have experienced a tremendous amount of drought and failure of these systems. Soil resource depletion, again, biodiversity is a really aggregate effect of climate change. Population growth. By most conservative statistics, by government and non-government agencies, looking at around 9 billion people by the year 2050. Now, 75% of those populations we estimate to be living in highly dense populated areas within the urban sector. These are where infrastructures will still be. These are where people will migrate towards. That will lead to the rise of megacities, places on this planet that will have 20 million plus people living in a small area. And what that's going to do is the more people that are on this planet is obviously going to lead to a huge rise in the need for land, energy, water, the simple calories just to be able to feed everybody. Housing and medical services are going to go through the roof. So what happens if we look at the potential impact of this increased demand and our inability to be able to, or some of the factors that will lead to that? Pollution, whether that's air pollution, water pollution, noise pollution. The increased activity is going to lead towards an increase in the overall pollution that's in our atmosphere or in our environment. Population growth could lead to conflict and wars. The more people you put in densely populated area, risk of disease goes up. A lot of these happen because of failure of infrastructure. Our sanitation and waste management, maybe a disruption in trade, disruption in medical services, inability to educate everybody, the inability to provide adequate law enforcement or even housing. And then rise in income inequalities. This is sort of an indirect effect of global population becoming more and more affluent, leading to also the rise of more and more people becoming and living in more poverty. And obviously, deforestation also being a cause of people needing more space, needing more ecosystem services, and using those ecosystem services probably inefficiently at best. So again, this is where it gets into what I'm passionate about, is that looking at the food that we consume and produce and what that effect is, not just on our human health, but as well as the environment, as I touched on at the beginning of the talk. So without going into each one of these individually, we know there's a rise of food-related diseases. A lot of that through a public health and epidemiology lens. Thinks about those as usually quite possibly related to simply the food that we eat. Or even lack of options in the food that we eat. Food insecurity and famine is still an issue because there is an unequal distribution of our food resources. Like I said, there's a higher rate of obesity, but at the same time, there's still a tremendous amount of food insecurity, especially here, even in the state of Washington. 30-some% of the families living in some sort of food insecurity, and meaning in which living in some sort of phase of food insecurity in which and what that means is that inability to know exactly where your food's coming from at a given moment, really. Food deserts, these are places with highly calorie-dense food, but lack the healthy options of that food. So nutritional education is important. Also the pesticides, again, that we use on the food production is a little skeptical. Pesticides and the glyphosate fertilizers that are really mostly in the news today. Think about pesticide exposure and what those could be doing to the health effect. So agriculture runoff being an issue with environmental, so this leads to ocean acidification. We also have a problem with soil degradation, as I mentioned before. Pesticide residues built up in the environment within our soils, decreasing the biodiversity, increase of pests, weeds, pathogens, are all leading to a big decrease in adaptability. So this is the ability for the soil to replenish itself, to go through the nitrogen cycle, to be able to provide healthy, nutrient-rich soil again, is slowly depleting. So how do we change this? Right now, this is the major current model. This is how we do this. This is like I said, it takes us back 10,000 years to our beginning evolution of our thinking. So going against that might seem, a little strange to most, I think is fair to say. So how would we do that? How would we go away? What are the things that we need to do to use less water, use less land, maximize those yields, decrease that transportation effect? And that goes in, now we're going into a little bit of my research. So like I said, I want to provide a working definition of hydro, aqua, and aeroponics. Really, these are just split apart terms of hydroponics. Hydroponics is the growing of plants in a non-soil medium, so usually immersed in either some sort of water, nutrient-rich base, and then sort of growing within that. The split from aquaponics, and what makes that unique is that is a closed loop system that uses fish culture. So uses the fish waste produced by the fish in a holding tank. That water is pumped to plants and then essentially filtered. That water is filtered naturally by the root systems and then brought back for clean water to the fish. So it's really a great, sustainable, low energy, low cost model that has potential to have great impact. And then aeroponics. This is some of the technology that I use, and what makes this different than just hydroponics is that instead of the roots being immersed full time or with water constantly rushing over the root system, they use a misting system. So usually water is either atomized or split apart, aerated, and stretched out over the entire root structure, and then the water articulates back down. These also use a timer, so they're not constantly running. So they usually use a mist system for an interval of like 1-to-1, so 15 minutes on, 15 minutes off, and then again and again all day. So my research that I get a chance to work on at Bothell with my mentor who's here today, Dr. Charlie Rasmussen, looks at symbiosis. We know that, and as I've touched on a little bit through research, that all the organisms, plants, and species living in the soil have some sort of interaction that's helping that or aiding that process or maybe even detrimental to that process. But we know that if we look at plants that thrive in a little bit more harsh conditions, ones that thrive in high salt or salinity areas, higher CO2 areas, higher temperature, most likely they have some sort of biological interaction that's happening with them on the root level that's really aiding in that process and probably benefiting the plant to be able to grow in that harsh environment. So symbiosis is the interaction between two different organisms living in close physical association, typically to the advantage of both. So what we've done is that from understanding that symbiotic relationship that's happening in the soil, what we wanted to do is to see if we could duplicate that same symbiotic relationship out of the soil. Could we isolate certain fungi and get that to interact with the plant in an enclosed system so that we could look and to try to study about water usage, drought tolerance, energy usage, to see if there's a benefit or even possibility that these relationships can be matched outside of the soil. So in a small experiment that we did of two we had two grow towers. If you saw the beginning picture, is a good representation of those. 28 plants per tower, one experiment, one control. They both receive the same drought conditions, same growing conditions, same period, same light, everything. The only difference is one had been exposed to the fungal endophyte that we were identifying. So if we look at the results of that experiment, we took the total biomass of each tower, so it was 28 plants, measure the total weight of wet, if we look at just the wet weight, which is the third bar in, and we measured the total biomass. So this is the total weight of the leaves and the root structure, and looked at that as a whole instead of identifying different characteristics. So of the group that was exposed to the fungal endophyte, we saw a 63% increase in the overall yield that was produced over the entire same 28 plants. So we feel like we were onto something with that. Now what we want to do is be able to take that a little bit further and see if we could really maximize these benefits. Can we increase the drought tolerance, tolerance to pest, disease, heavy metals, higher CO2s? Because not just within the soil having huge implications, we feel, or I feel, that what we could do is that we can make these systems already a little bit even more efficient. We'll get into some of the limitations later on, but these systems, these hydroponic systems, utilize energy, lights, and things like this. They require pumps to move water around these large-scale systems. So the economic advantage to making these more energy efficient, more water efficient, makes sort of leads to the argument that maybe this is a way to move forward with that. We could also get into what organic labeling means and how possibly hydroponics or aquaponics would actually even be considered. Organic under these terms is really depending on a biological diversity component. So other objectives, like I said, improve water use, increase those yields, and I think a lot of that's going to have a great advantage if we think about these things in large scale models. So what are the benefits? So we talked about climate change, we talked about population growth, we talked about the human health impact. So some of the advantages, I think, of creating systems that are directly in our urban and rural food deserts already have at least the ability to decrease the transportation effect of our agricultural system, which is a big component leading to an increase in CO2. Most people, like I said, we look at the food on the shelves. Hey, we live in Washington. That's an apple. That probably came from Washington. Probably not, actually. The food that we eat and consume, even organic, still travels vast amounts of miles to get to us. And I'm still just focusing on just plant production. So we can get a whole nother topic about our meat production system. So by utilizing indoor space, by using our built environment directly in these urban and rural food deserts, one of the biggest advantages is that through engineering, we're going to be able to maximize our yields per square footage by growing directly on the ground level as well as the level above us. And that's obviously a big step forward from our conventional model, because we go out there and we lay crops and they grow in rows, and we need vast amounts of land to grow more. So the ability to be able to take something that looks like this and make that feasible is really going to maximize the space that you actually need to grow a lot. Uses 90 to 95% less water. This is not new technology. Even NASA, Walt Disney did this in the 50s and 60s. You can go to Epcot today, and there's still a big hydroponic farm display that they have here. So, and they're some of the people that have done the fundamental research and continuing emerging research that when I say uses 90 to 95% less water, it's a lot of that because a lot of the water has the ability to be recycled and reused over and over again versus, the typical spray method that gets evaporated and hopefully eventually makes it back into the hydraulic cycle. But that's a long process to wait for. Well, you control the environment. That's a big advantage. By controlling the environment, you move towards at least away from the argument that says, well, you need pesticides, you need herbicides, you need fertilizers, and you need GMOs to maximize all this production. Well, a lot of those are because of you're using outdoor space because you need to prevent against these things. So that's a sort of obvious answer to that. But without getting into too much and splitting hairs about which one is right, which one is better, I think by controlling the environment, you obviously eliminate a tremendous amount of need or the argument to even have them in the first place. So as I mentioned, decrease the transportation effect, and you create a year-round growing cycle. What is important to understand is that a lot of times, if you take a place like Jackson, Wyoming, here's an affluent community, a rising community, who has a limited growing season of about 6 months at best, on their best day. They're in the process of developing a large-scale model that actually is going to be able to feed that population year-round by controlling the temperature, by controlling the airflow, by controlling all these different things. You create that year-round model. Increase awareness. This is sort of an abstract thought process. Increasing awareness, I think you create visibility of these type of models. If one was right here on campus, if one was right here in the community, I think you would know it. I think you would see it. I think you would probably be interested in understanding why it's there. So I think the visualization, because right now we've completely displaced farms and farming opportunities with the rural sector, and most of us who live in an urban sector sort of just don't even engage or even think about that thought process. So supplying food to low-income families, this is hopefully a byproduct. If done through a public health lens, done through a social benefit need type corporation, or somebody who's looking to do research at a foundation has the opportunity to create this kind of model that would essentially supply food to low-income families by putting these directly in those food deserts that we talked about before. So shorter growth cycles. This just means, obviously, well, I think what it says is that through hydroponics actually has been shown to have rapid growth rates compared to the same crops grown outside. But can it be done? This is a lot to endure. This is, I think, a lot done to go. We're talking about utilizing buildings. We're talking about utilizing all this different technology and all this different energy that needs to come in. So, as I mentioned before, I think it's hugely important to understand the limitations. And I think this is for any of the students in the room. If you focus a lot on the limitations of your project, you're going to find outcomes that either change or object to that model, or at least move towards finding ways to connect your interests in a wholly different holistic fashion, or maybe an interdisciplinary way. So limitations. So I mentioned that we are taking indoor space and we're trying to maximize this airflow, maximize the efficiency, maximize the temperature. And that's going to take a tremendous amount of energy use. The U.S. Energy Policy Committee just released a report that said marijuana farms that are doing this in the state of Colorado increase the energy use by roughly 3% just from their usage. So we have to really understand where that energy comes from, because if we're talking about being more sustainable from an entire huge carbon footprint perspective, then, well, where is your city? Where are you growing it? Do they use coal power there? How is that place being entered? So looking at all these different avenues and how to understand what energy use means, but also understanding what the trade-off is, because the typical industrial conventional model uses a tremendous amount of energy. They use fossil fuels, not just to transport, distribute, create, but also in the production of the pesticides and herbicides, are petroleum-based agents that are used. So we need to find a way to create value for different energy sets versus the traditional model, and really start looking at carbon or life cycle analyses of all these different entities, and really match up to see, well, which one is doing less and or more, instead of just going with, hey, the outdoor one works better because I could just go out there and plant seeds and the sun and water does it all. Upfront costs are going to be a real issue. What does urban space go for? Where is it? Is this in New York? Is this in London? Or is this in Omaha? I don't know, because there's going to be a vast difference between those upfront costs of those three places. So, and is there real estate? Is there even place? Is there, maybe a place like Oakland that has a tremendous amount of industrial space, or Chicago? But if you look at Seattle's real estate market, there's not a lot of space being just popping up or being built. So how this would fit into Seattle is a little bit still a little understood. So are you building new construction, rent on urban spaces, higher carbon footprint question mark? That's kind of what I was alluding to. I don't think we really know. So how we trade off, or what the trade-off is, what we're willing to put energy use into, I think is really the bigger question. So monocropping. I put monocropping in there. I didn't touch on that concept, but that was a big change in the way that we produce our food, going back to the Green Revolution. We maximized our space by focusing on one variety and doing that, stretching that across the board. A lot of these models, the hydroponic and indoor models that I see across the world, are also doing the same thing. They're maximizing their economic return by focusing on commodity, well, maybe not traditional commodity crops, but niche markets within microgreens, lettuces, and things like that that they're hoping to really just maximize the economic benefit for this. And I think that for me, I'm looking at it from a little different lens, and not just the economic viability, but how we create more biologically diverse systems. Well, it's important because we know that even just direct relation to different crops in the same spaces lead to better, not just the soil, but even in the same spaces are leading to better increased growth. Limited market. Again, like I said, this is a niche. I think right now it's on the periphery of our thought process. So the consumer who's looking for organic specifically will not find hydroponically grown organic foods. By focusing on the microgreens and lettuces and stuff, you're really appealing only to a certain consumer, I think, and not maximizing that. And right now, a lot of the crops that are being done are those lettuce and microgreens. If you're creating a Feed the World model, even though these are nutrient-dense plants, they're not. We need more things. We need tomatoes, we need peppers and cucumbers and all these other things. And I think right now we're only limited by our imagination. Because as I showed you, there's really only about 4 or 5 different models that these look like. I showed you that tower one, there's some other ones, but right now we're limited in our engineering imagination and our ability to think, well, can we grow corn inside? I don't know. I mean, that's another question for somebody else, or to be asking those questions as we continue to push this conversation. So right now, there's not a lot of design models that really seem to match up to that, or grow wheat or grow corn on higher stalks, and how do you place that on top of each other and all those different things. So labor intensive. Right now, any agriculture production is going to be labor intensive. So until we move towards a model that has more automation and more robotics involved in that, but that's a whole other conversation about labor and equity and how these things work. So I wanted to make a connection, though. Each one of the things that we have talked about today have their own avenue, have their own ability to focus on just the sustainability component, just the population growth mitigation, the engineering component. So all these things, and we'll try to connect this through about 15 minutes of Q&A after this. But again, so as I kind of alluded to, labeling being an issue right now. USDA and the National Organic Standards Board set what is organic. Without that, without those without those characteristics or definitions of organic, hydroponic is very limited. If you think from a consumer standpoint, I think that consumers identify three things when they think organic. They think it's healthier, they think it's pesticide-free, and they think it's environmentally friendly. Three of those things aren't necessarily as accurate as you may think. An organic banana can come from Panama that was shipped 1,500 miles away. Transportation effect doesn't influence organic labeling. Pesticides, there's many approved pesticides for organic production. What really came down to, and after peeling this apart and looking at it from a policy perspective, it really turns out that organic means biological diversity of the medium it was grown in, meaning how diverse or how nutrient rich is the soil, what are the bacteria, what are the agents that are acting in that. And so if you've created language that says, well, biological diversity of the soil or that it's grown in, it kind of makes it hard for hydroponics to sort of fit into that model, regardless if we're trying to advocate for the environmental sustainability of it, the lack of pesticides and all these other things. So powerful lobbyists will block this right off the bat. I think that this is a concept that really pushes the agenda away from our status quo and our normal way of doing things. And there's lots and lots of vested interest in continuing to uphold the model that we're talking about. And then it comes down to consumer education, the consumer being able to decipher between what is accurate, what is organic, is this thing, hey, here's this hydroponically grown lettuce in my grocery store. What is it? It's like Frankenfood. Right? Is that so I think that kind of gets associated with anything that we're doing new, or hey, that's grown, or we're using fungal endophytes to increase the drought tolerance to that. I think, well, what's that, GMO? So there's going to be a disconnect. There's going to be a huge hurdle to overcome if you think about that. And this is one of the things that I'm most passionate about that I think is fairly accurate and fair about this industry is that all the inputs. They don't use the best inputs. Most of these things are created of plastics. Most of them are using some sort of synthetic fertilizers. They're using, for one example I'll give you, so rock wool, really one of the industry-leading standards for germinating seeds is a mixture of limestone and something else, and it's kind of made like cotton. I like to say like cotton candy, where it's just spun at such a high level that it forms a sort of a fibrous rock, and it holds. And what makes this great is it holds a tremendous amount of water, so you can actually just water it one time, germinate some seeds into it, and then transfer that into a hydroponic system very easily, limiting the labor. But these things will never biodegrade into a landfill or anywhere else you want to dump it. I mean, if it does biodegrade, it's going to be thousands of millions of years from now. It's a rock in just a different form. So there's a lot of issues in the environmental sustainability of the components. So that moves into sort of our next slide. Interdisciplinary thinking is a strong foundation for any academic who wants to take their research further. A lot of us as academics, we focus so much on what we are interested in. And I think we do that because we want that to be the new norm or the new thought or the new, you want to be the person who said this thing that people latch onto. But if you don't understand all the historical, cultural, medical, or health implications, economic implications of what you're trying to accomplish, you're going to have an uphill battle. If you don't surround yourself with people who are also thinking in these terms or thinking interdisciplinary, you're going to have an uphill battle. What I am fascinated about thinking about this, and as I said before, it branches off in so many different components. You can make a career just focusing on population impact of agriculture and just that. If you, or the fungal symbiosis, or the engineering, the mechanical, industrial engineering, the robotics, the animation, grant writing, So some of these are sort of career trajectories, some of these are academic opportunities. But I think if you look at this list, every one of these, I think, appropriately fits into that model. because I look at myself as I go forward and wanting to do something like this, is I am very few of these things. I am not a biologist by trade, but I know biology is a huge component to why this thing will work. I'm not an engineer by any stretch of the imagination, but I know that that's who I need to surround myself with to make this type of model work. Public health, you need to understand what are the social determinants, where we live, our environment, the food we produce, our social economic standing, our race, plays directly into our health impacts, and how we create public health interventions to mitigate those impacts is truly important. Environmental science, nonprofit models of doing this kind of stuff. So very interdisciplinary and very much a needed field, I think, an emerging field. So if anybody who's interested, just continue to plot out your direction, think about how this ties back to your interests, or not this per se, but anybody and whatever your interests are, finding ways to create that holistic perspective about it, and it'll be good. It'll change the world. So I think that's about it, and we left a few minutes, so that's about 15 minutes. So any questions? And I'll do my best to answer them. So a lot of it would probably be my opinion, really.
I have a question from someone in the audience that I'll ask Nick. Someone's shy and doesn't want to ask a question by himself. Todd? Oh, okay. Washington has a growing marijuana industry. You mentioned it earlier. That's what triggered it. Due to their history as a hidden industry, marijuana production, have they been an early testing ground for this hydroponics kind of research that you're talking about?
Absolutely. It would be silly to say that they didn't. Marijuana production and hydroponically grown it really sort of setting the standards. Obviously, there's different needs as far as how and the type of inputs that you use, but the principle of it is very much there. Understanding how these models use energy is probably one of the best ways to understand how we move towards doing something different. As I mentioned in Colorado, an increase in total overall energy use for the state, simply by and a lot of that is brought inside because of limited growing areas. So the concept is still there. I don't think they're not necessarily that mutually exclusive. They could be looked at as appropriate models. They both serve different functions, obviously. Mine just happens to be focusing on whether we can grow tomatoes the same way or whether we can grow lettuce the same way. No. As you, bud.
So you brought up soil degradation. Is there any crops that you feel we should be moving away from, at least until we perfect this type of technology, or should we just move away from them in general?
Particular crops we should move away from?
Yeah.
I don't have a vast amount of knowledge about that, so I'll kind of comment on just whether we should be moving away from anything. We have continued to systematically decrease the amount of different varieties of food that we have in our production, basically making some of them almost extinct or non-existent or only available in like small niche markets somewhere in other parts of the world. So I don't think it would be ever fair to say we need to move away from anything. But I think if you look at the crops that have the most impact or use the most monoculture designs, are the most pesticide, herbicide, fertilizers, and GMO intensive, well, that's our big commodity crops. That's corn, wheat, cotton, soy. But we're not moving away from them, but how we use them or how we maximize or why we maximize those, I think, is important to at least try to understand or maybe sidestep from.
Nick, if you mentioned energy and the bit of a conflict between energy use and the obvious benefits of this. Have you seen any innovations in the area of energy where people have tried some things that will reduce the amount of energy used in hydroponics?
HVAC and new technology within just how airflow and temperature is managed and doing that efficiently can lead to huge benefits within these types of systems. Models that have the ability to create from new or from scratch have the advantage to incorporate that kind of stuff. But obviously, if you're using or retrofitting space, you have inefficient HVAC systems. And then another thing is that, well, if it's new construction or if it's renovated construction, or if you try to think of something in related to like the Bullitt Center, and the Bullitt Center downtown, who utilizes their own energy from solar panels on the roof. Obviously this is an artist rendition, but there's wind turbines, on the roof. There's solar panels on the roof. So if we could start to, move towards that type of model, then I think you could already start to decrease that stuff right away.
Hi, Nick. So there's evidence that organic foods have more nutritional value because of I don't even know why, but they have more nutritional value. They actually tend to taste better too. The question I have for you is, do you know or have any studies been done on what the nutritional value of foods that are hydroponically or aeroponically grown have, considering the inputs?
Okay. Full disclosure, that's my mentor, Dr. Charlotte Rasmussen. So she knows what I do know and don't know more than anybody.
This is something we should look into.
So I'll give a kind of a critique about that. A short answer is no, specifically hydroponically grown, nutritional value of hydroponically grown vegetables is something I would very much like to understand. How these foods are tested also is another thing to understand. I know that there's somebody that I'm directly connected to at Bothell, a professor who's undergoing a study specifically about the nutritional content. A lot of these standards and nutritional contents of items that are produced by the USDA, when you get to look at the back of, you see your label, they're not based on the food itself. They now take that Cliff Bar and analyze that Cliff Bar. They analyze what's already been done as the components or the ingredients of that Cliff Bar, and you run that through a formula, and then it pops out, it says, well, it has this much fat because this ingredients are in it. What makes that hard is that there hasn't been any additional or continued follow-up on a lot of these things. Some, like and I'm just maybe making this up, but like the standard for an orange, or what an orange had, was probably set 40 years ago. We've completely changed the way food is grown, the soil is grown in. So it's tough to say that, what, if anything, that we're looking at holds water to the actual true, maybe more like baselines for people to kind of understand, these are many calories are in it, and this is how much fat is in it. And back to the lobbyist comment, about a few years ago, as anecdotal example, is eggs came out and said they were high in omega 3s or whatever. And that study was done on an egg, just an egg. And then the egg lobbyists spent millions and millions of dollars for the USDA to be able to say that. And even the USDA, rejected at time, but because of oversight or not wanting to dive into that deeper. So not to be critical, overcritical. Really answer is yes, we want to, right? We really want to know, because I want to know from a policy standpoint, how can I change the public perception of organic labeling, and can we have enough evidence to show that it really does provide a different nutritional component that's being sort of packaged and sold to us.
Hi, I have a sort of a combination question that's historical, cultural, and political.
Okay.
So you showed some historical images of farming, and there's this great nostalgic idea about farming and family farming that is built into our literature and our cultural heritage, in our political heritage, if you think of Jefferson and the Yeoman Farmer Republic. So right now, in my experience, there's this disconnect between the fact that we have this nostalgic image of the individual family farmer, when in fact, almost all of our food is grown through corporate models.
Yeah.
But this hydroponic model makes it that much more obvious that it's not a family farmer
Yeah.
that is harvesting your heirloom tomatoes.
Yeah.
So one of the attractiveness things about organic farming and having sort of, truck farms and going down to the Pike Place Market even, is that you have this nostalgic image in your head that some individual farmer grew this heirloom tomato. Whereas if you're doing it in this hydroponic thing, there's no illusion that it's grown by an individual family farmer wearing overalls. So what I'm kind of in a roundabout way suggesting is, how are we going to go about, in terms of changing public perception, in creating some kind of a positive political, literary, cultural narrative around this type of farming? Is there any way to get from where we are in our cultural heritage about farming, which is disconnected from what the current practice is, to going forward with a different type of practice than what we're currently doing, and even making that acceptable?
Yeah. So that could be a PhD thesis, right? Like that whole thing, and understanding that appropriately. There's so many different avenues that I could really want to explore with that, but I think the best way to try to answer the question best is that when I see these models, I essentially vision them probably in a different way than they are being envisioned with automation and all this other stuff. We know through some research, social science research, that simply engaging in the agricultural process has beneficial health or outcomes, right? Just digging in the soil or just working with that is kind of what you alluded to. So when I see these models, and if I'm coming at it from the public health lens, and I'm looking at this as a public health intervention. So this is specifically to increase outcomes. So whether it's health outcome, whether it's a mental health outcome, I think the best way to tackle that is through the interaction, right? You have to understand the interaction. These places have to be somewhat quasi-inclusive in a way that you bring, how do you utilize labor of veterans, right, for rehabilitated PTSD? How do you create educational components by bringing in early childhood education, starting with that, and a lot of the stuff to overcome the historical and cultural, a lot of that is dependent on time and time that we have engaged. So right now, I think the concept of thinking whether the stories will be written, seems like very far-fetched. But I will say that Elon Musk and anybody going to Mars isn't growing poo potatoes, right? They're taking this technology with them. So maybe that's for the stories, right? Just recently, they produced lettuce and flowers on the International Space Station with this technology. It's kind of the only way that it will kind of move into the periphery if other people are advancing it in different and maybe cool ways, or ways that could be viral, or ways that could. But I think from my goal is to see how these communities interact through that sort of rehabilitative labor and early childhood education labor, not labor, early kid labor, and so thinking about it that, and I think that a lot of those questions will kind of start to be answered.
Maybe. Kind of going along with what Dean Kinsel said, I was wondering about like the maybe special interest groups that would not be interested in this pushback, or you kind of mentioned that I think in one of the slides.
Yeah, I mean, that's, you know, we can even move away from agriculture as being the top subject, and we can think about anything that goes against our social norms or changes in thought processes. There's automatically, or sort of automatically, but usually a general pushback. So I think that in the early evolution of this type of technology, we will see or experience some levels of pushback on all phases. And I think that's sort of important to understand from a policy perspective, like going back to, again, what my focus is. In policy, it's more advantageous to look at incremental changes that can start to move down and have larger effects down the road. Because if I got a policy degree, I got public involved, I created an advocacy group, we wrote a bill, we did the stuff, we did some research, and we tried to make a huge overhaul of our agriculture model. That is not going to happen. But understanding why hydroponics could be related to organic, moving that into how public funding could be used to create value of serving underserved populations becomes another. And then sort of down the road, you continue to build momentum, and that's really how change happens. Incremental changes, unfortunately. I mean, we all want it to change right away, very quickly, but it doesn't happen like that, so.
Okay, well, I think we're just about out of time here, so please join me in thanking Nick for a very interesting talk today. And thank you so much.
Thank you.